Thank you for the invitation. This story really starts with housing. Let's see, here we go. So as many of you know, we have been transitioning egg layers in this country from cages to cage-free, and this was really prompted by legislative changes as well as consumer demand. So with all of these large companies getting on board and making these declarations, that really was the impetus to start to see this transition to cage-free housing. And this transition has happened relatively quickly. When I started my PhD back in 2011, this was one of the farms I worked on. This is here in California. It's a relatively small farm because there's only one row of battery cages, but this really was the standard housing. It was these small wire cages with animals up off the ground and away from their feces. For a short time, it looked like there's going to be a transition from battery cages to enriched cages. So the animals were still going to be confined, but they would have more space per bird, and there would be these enrichments such as perches or scratch pads inside the cages with them. But really, we skipped right over that and went to primarily cage-free housing. And here in California, this is now our standard. As of January 1st, all eggs sold in the state of California have to be from cage-free poultry. And these properties may or may not be organic, so they might go that extra mile to make this organic. But we still do have quite a few conventional farms that have adapted to this. We're also starting to see an increase in what we might call open environment or pasture-raised poultry. So in these systems, the birds will have access to the outdoors most of the time, and then they'll have some sort of shelter in the form of a mobile coop or something for egg lay and at night. And you're, entomologist, why are you talking about housing? Well, from a parasite perspective, if you look at the birds, the parasites that live on the chickens, they don't really care where the chickens are. They don't care if they're inside in battery cages or if they're outside on pasture. And that's really what I'm going to talk about today, is these two primary ectoparasites, the northern fowl mite and the chicken body louse, and how they really thrive in any of these environments. So let's start with the northern fowl mite. This really is our primary poultry ectoparasite here in the United States. These mites are permanent ectoparasites, which means that they complete their entire life cycle on the bird. And the northern fowl mite prefers the vent region. So if you look at a chicken and those fluffy feathers near the butt, that is the prime location for these mites. And the mites will spend a lot of their time in the feathers. That's where they'll lay their eggs. And then they will travel down to the skin surface to blood feed. And they require this blood meal to develop and reproduce. One of the interesting things about northern fowl mites is they have a very short life cycle. So they can go from egg to adult in as few as 5 days, which is very fast. And because of this, we can see populations grow very quickly. And I'm going to show a video of a bird. This is only 4 weeks post-infestation. And all these black dots, these are my hands, and all these black dots are going to be adult mites crawling around. So these are just thousands and thousands of mites on my hands, let alone what's on the bird. Luckily, they are poultry mites, so I don't worry about bringing them home or being bitten, which is really great. Now, the economic impact of northern fowl mites has been very well studied in battery cage systems. So we know that through their blood feeding, they can cause anemia or even mortality in birds in extreme infestations. But more importantly, we do see decreased egg production when there are mite infestations. We see decreased feed conversion efficiency. So the birds need to consume more food to produce the same amount of egg. And A study that was conducted on a commercial farm here in California very closely tracked mites over time and the economic output from that farm. And they were able to demonstrate that in a 10-week period where mite levels were very high, there was a profit reduction of 7 to 10 cents per hen. That might not sound like a lot, a few cents, what is that? But at the time that the study was conducted, the profits were about 7 cents per dozen eggs. So mites can have a very large economic impact on egg layers. Chicken body lice are a little bit different from the mites. These are larger organisms. They're a little bit easier to see. They are found all over the body. They're not necessarily restricted to one region or the other. And they are much slower growing. So the lice tend to take 14 to 21 days to complete their life cycle. So you don't have the extreme population growth that you see with the mites. Now, chicken body lice are primarily feather feeders. So if you can see here in these circles, the feathers look thin. And if you have a heavily infested bird, just from looking at her, you might have what you would call like a lousy bird, like their feathers just look thin and unhealthy. And that's because that's mostly what they're feeding. However, they can get blood. In fact, we can see that this dark midgut right here. So they can get blood from pin feathers and chewing on those. So they are generally classified as feather feeding and occasional blood feeders. And another telltale sign of the chicken body louse is their eggs. They will lay them in clumps in the feathers, and it's almost like they Velcro them. And so you'll have these big, just clumps of eggs holding these feathers together. And just to mention, chicken body lice have been linked to economic damage, but it's not as clear as with mites. And there's actually some discrepancy in like how damaging. So currently the thought process in the industry is mites are very bad and lice are tolerable. So this push toward changing housing has really been driven by an increase in this, why we're here, this betterment of well-being for the birds. And there is a tool, the Welfare Assessment Protocol, that provides opportunities to measure a variety of different on-animal and environmental factors that help to quantify and standardize welfare. And this tool can be used either between farms to evaluate welfare or even within a farm over time. And there are 4 principles in this assessment: good feeding, good housing, good health, and good behavior. Now, I am coming from an entomology background. So when I was looking at this, one thing that really stood out to me is that arthropod pests and parasites are mentioned, and are they present? Yes or no? And that's really a gross oversimplification of the impact that ectoparasites might have on birds. And I suspected when I first saw this that at the very least they would be impacting both the health and the behavior of the birds. And that's really what the impetus for this whole study was trying to get at more how these parasites might be impacting the overall welfare of the poultry. And I chose to use both of these ectoparasites because they are different, different life histories, different feeding strategies, to try to see what their impact might be and if their impact is different from one another. So to do this, we used the welfare protocol and we used these animal-based measures. And I was trained by a poultry scientist, don't worry, to improve my skills. And then for the behavior part, we actually used on-animal sensors. And I'll spend a little bit of time talking about that when we get to behavior. So for the welfare quality assessment, we used a subset of the animal-based measures. And they're all listed here, but I'm just going to highlight a few. The presence or absence of abnormalities to the comb, so looking at comb wounds, looking at soiled feathers, and also looking at skin lesions. So while we measured all of these metrics and we recorded all of this, these were really the three that stood out in our studies. And all of this mite work is published if you want to read more in depth. The louse work is in progress. So I'm going to start with the mites, and I'm going to first show the mite population changes over time. So we had several points across the study where we took our welfare and behavior measurements, starting at week 1, where there were no mites in any of our flocks. And then at week 4, we took measurements again. This is where we have what we describe as low mite levels. So they are growing. We have up to 100 mites per bird at this point. At week 7 in the study, we took another measurement. These are high mite levels. Now we have thousands of mites per bird on average. And then we actually treated all of our birds. So we went in with a chemical treatment and we eliminated mites from our birds, and we took another measurement at week 12. So this would be what we called post-infestation. So all of these birds have previously been exposed. Now they are clear of the mites. And then in 2 of our flocks, we re-infested them. And at week 19, we actually had a head-to-head comparison between flocks with mites and flocks without mites. And we had 4 flocks in this study. Each flock had 12 birds. So lower numbers, but each bird was measured every single week. I'm going to start with the welfare assessment. So these first 2 time points, so no mites and when our mites are low, we actually don't see abnormalities. One bird here or there that had soiled feathers or comb wounds, but we really aren't seeing anything out of the ordinary, and nothing, significantly different from our control baseline, no mites present. What we start to see differences is when we have high mite numbers. Every single bird that we looked at had skin lesions present, and some of those were scored severe. And almost all of the birds we looked at had comb wounds present. We also did see soiled feathers, which was significantly different from our no mite levels, but this was not as universally observed. And then after we treated and we removed those mites, we actually saw a return to our baseline levels. So we see skin lesions gone, no skin lesions scored, and only, again, that one soiled feather. When we do our head-to-head comparison, where half the flocks had mites and half did not, so on the left-hand side, these are our flocks that have no mites, and on the right-hand side, these are our flocks with mites, we do see a significant difference in our skin lesions. So here, only the birds that had mite infestation had skin lesions scored. The interesting thing is, if we had stopped the study earlier and we had the comb wounds at high mite levels, we might have thought that comb wounds were related to the mite infestation, which we can see down here at the high mite levels. But here, we're actually seeing that there are more comb wounds scored in our flocks with no mites. So there's something else going on with the comb wounds. It does not seem to be linked to our mite infestations. All right, so now let's talk about behavior. I mentioned that we used on-animal sensors, and this really started from an idea of what if we could put Fitbits on chickens? And then we were like, well, we can't really put Fitbits on chickens. What if we made our own? So these are accelerometers, 3-axis accelerometers that were actually developed for medical research that we decided to put on chickens, and they wore them on their backs in these little homemade backpacks. Very technical, you can see. And the way that we developed the software was we were able to pull out when a chicken performs a behavior, it shows up as a distinct pattern on the 3-axis accelerometer. And by collecting a lot of known data where we knew what the birds were doing and where the sensor output was, we were able to work with computer scientists here at UCR that were able to develop an algorithm that pulled out these patterns. And so we had 3 behaviors of interest that we were looking at. We have pecking behavior, which we thought might be a proxy for feeding. We had preening or grooming behavior, and this could be anywhere on the body where the bird was preening the feathers. And then we had dust bathing as one of our behaviors of interest. And this did require a lot of video camera work where we observed the birds and we knew what behavior they were performing when, and then annotating the output. And this is one example of when the bird is pecking and what that output looks like. And this is about a year and a half of work that I'm summarizing onto 2 slides. So I'm happy to answer more questions about this later. So what we did was we put these backpacks on the birds for a week at a time. And so every single animal had a backpack on. And then we downloaded all of that and ran our algorithm through. And we got an average number of behaviors per bird in that week time. And for pecking, we can see after week 1, we generally see a little bit of an increase, but overall pecking was very stable, regardless of the mite status of the birds. Dust bathing was a little bit more variable. We'd have a general increase up to when the mite infestation occurred, that first mite infestation. And then post-treatment in 3 of our flocks, we see a decrease in dust bathing behavior back to about that first no mite, what we call our baseline. You know, this was birds before there had been any manipulation. But we did have 1 flock that had an increase in dust bathing, and this was one of our infested flocks. So I'll talk about this a little bit more at the end, but dust bathing is complicated, and I think that this just helped to reconfirm that it can vary widely based on other factors that we weren't measuring. Preening is really where we start to see some interesting patterns arise. We had very similar among our flocks preening behaviors, and then we did see increases as mites increased in this preening behavior. It dropped in all of our flocks back to our baseline levels post-treatment. And then we see this very nice separation here. And these 2 flocks were our infested flocks. So we saw significant increases in preening behavior in infested flocks compared to uninfested control flocks. So quick summary of the northern fowl mite work. Are mites impacting welfare metrics? Yes, we saw some increases in feather soiling, but really skin lesions. This is not completely surprising based on how the mites feed. So the mites are blood feeding in this vent region, but then there's also a known immune response to northern fowl mite feeding, and it's in the form of inflammation in that vent region. And so this is one of the signs of the immune response is this scabbing and the covering of these lesions. So this is not surprising at all, but being able to measure and quantify this was really important. And what about behavior? So we do see an increase generally in activity during the first mite infestation for pecking and dust bathing. And just when those initial mite levels are high, but we don't necessarily see that repeated during that second infestation. And this might be related to immune responses also, where the initial mite response is having more of an effect on the birds than that second one because they've been primed. This is still somewhat of an untested hypothesis. This does require more work. We do need to replicate this, but right now this is kind of our starting point. What's really interesting is regardless of if it is the first infestation or second infestation, we do see increased preening. So that is a consistent result we saw when mites are present. And we did look at the mite load on individual birds. So that was one of the nice things about having all this individual bird data. And it doesn't seem to matter how heavy those mite infestations are. It's just the presence of the mites that is impacting the preening behavior. All right, so now let's transition from mites to the lice, which, as I mentioned, are not quite as well studied in terms of like the economic impact or impact generally on birds. So for the lice, we were able to get 2 complete trials in, and we set it up a little bit differently. So first, trial 1, we started week 1. There are no lice on any of the birds. That was our baseline measurements for both welfare and behavior. And then these lice are more slow going. So we planned ahead of time to take measurements again at week 7. In trial 1, the louse levels were still fairly low. That's when we took our second measurements. And then our third measurements were at week 12. And unfortunately, in trial 1, we really missed the highest level of louse activity when we had our measurements. And in trial 1, flocks 3 and 4 were our infested flocks. Same setup, 12 birds per flock and 4 flocks. In trial 2, we also, again, week 1, baseline, no parasites at all. And then we moved our second time point to week 8 to hopefully get more mites on the birds, and that did work for trial 2. And then once again, we took our third set of measurements at week 12. So in general, trial 2 had higher louse levels than trial 1. And in trial 2, our flocks 1 and 2 were the ones infested. And I'll try to highlight that as we go through. So once again, we took all of these measurements and at these 3 time points, but in this one, only skin lesions is what I'll be presenting, because this is really where we saw the biggest changes, or in some cases, a lot of these measurements, we just saw no abnormalities. So starting with trial 1, we saw no skin lesions at week 1 or week 7. This is when there were either no lice, which was week 1, or very low louse numbers. So, but at week 12, we did see a significant number of birds that had skin lesions present. In trial 2, again, week 1, no skin lesions. And then in our infested flocks, we saw almost all the birds had skin lesions at week 8. And then again, a significant number of birds were had skin lesions at week 12. In our control flocks, we never saw skin lesions. So I'm not even presenting the control flocks here. We only saw them in our treatment flocks. And one of the interesting things here is I mentioned that lice are feather feeding. So we actually didn't expect to see skin lesions because they're supposed to be feeding on the feathers. And what was really surprising is, by noting this, what we think is happening is the adults are actually chewing on the skin, especially under the arm of the chicken. I'm showing this to you, like my arm is like a chicken arm. But what we see is that the younger lice, the nymphs, they like to be in the underarm region, and that is to avoid bird grooming. And we see the lesions there, and it looks like the adults are causing the lesions, perhaps for the nymphs to get blood. That's definitely something that's going to take some more observations, but it was very surprising for us to see skin lesions at all, and then to see so many of them in that region. So this actually might be a very cool louse feeding behavior that hasn't been documented before. I know I'm getting very excited. The chicken people are like, eh. But trust me, this is really cool, because again, this paradigm that they don't need blood, it's opportunistic. Well, it might not be so opportunistic if they're causing skin lesions, or if they're, how do these skin lesions occur? All right, and then back to behavior, we used this same system. We used our little chicken backpacks. And I'm going to start with dust bathing. I presented the data a little bit differently here. So each bar represents one of the flocks, and the infested flocks are going to be shown in blue. So at week 1, we have pretty consistent dust bathing across all of our flocks. So this is our baseline, no parasites present. And what we see generally is that there is an increase in dust bathing, but this is true for all 4 of the flocks. So this might be an age effect. This might be age, probably, maybe environmental, but it does not seem to be impacted at all by our parasites. And I don't have the statistics shown here, but we do see a significant change over time in all flocks, but not differences between our flocks. In trial 2, we generally see the same pattern. So again, our louse-infested flocks are in blue. At week 1, we see very consistent dust bathing behavior recorded in all 4 of our flocks. We see this generally increasing over time. And then we have one flock, flock 1, that is significantly greater. They're exhibiting more dust bathing behaviors than the other flocks, but this is not consistent with the other louse infested flock. So once again, dust bathing is complicated, and this might be socially facilitated behavior that we're seeing a difference in, or some environmental factor that we weren't measuring. Preening. This is where I get very excited. So in trial 1, again, blue is louse infested. We see very consistent preening behaviors across all of our flocks. And then week 7, this is where we now have lice in our infested flocks. We see a significant difference, and we see significantly more preening behaviors. And I'd like to remind you that in trial 1, we had very low louse levels at this point. We might have had a dozen lice per bird, and yet we are seeing a significant increase in preening behavior with very low levels. And at week 12, we still see more preening compared to our control uninfested flocks. And this pattern holds for trial 2 as well. So week 1, baseline, all flocks are very similar. And then in our infested, oh, this is a typo. This is supposed to be week 8. So that's when we took our measurements. We do see significantly more preening. And then that holds true for week 12 as well. So once again, the actual parasite loads don't seem to be impacting the preening, the specific score or number of parasites, but the presence of the parasites is really impacting this preening behavior that we saw in the chickens. So in summary, how did the lice impact welfare? So we saw skin lesions. This is very exciting from a louse biology standpoint, and it's also very surprising that we would see skin lesions on something that we assume feeds only on the feathers and might not be causing a lot of damage. And we do see more preening when lice are present, even when those lice are present in low levels. So this is a very strong response. Dust bathing, it's complicated. There are a lot of things that can impact dust bathing, but I think what's interesting is that parasites alone, and I think this has been shown before, but really just confirming that parasites alone are not driving dust bathing behaviors in flocks. All right, so now what? How can we use this information? So one thing that we might be able to do with this knowledge of how parasites are related to behavior is to use behavior as a monitoring tool. So if we have a cage-free flock, how do we know if there are parasites in here? At least in a cage system, there were some sampling methods in place, walking down and collecting X number of birds per row and examining them. You can't really do that in a cage-free flock. You might be able to randomly pick up birds, but that's very time-consuming and labor-intensive. So if there are behaviors changing over time, and perhaps we could use that as a tool, not only to determine if parasites are present, but the other way that we can use monitoring is to determine if there is a control method used on the flock. Did it do anything? You know, this way to determine if changes in management or changes in control method are actually having the desired effect. And so this definitely needs a little bit more refinement. We'd love to work with a commercial producer if there are any interested to really test this hypothesis and perhaps use behavior as a proxy for mite infestation or louse infestation. I also think that this tool could be used to refine what we know about the economic impact of these parasites. A lot of this economic impact work has been done in cages. And by putting birds in a cage-free environment, we're changing everything. We can't rely on those numbers because resources are going to be different. Birds are going to be doing different things. And all of this is going to be related to you know, how the bird spends their time and their energy expenditure. And we really need to look at this more closely in these new systems. So not only can we look at which parasite is present, is it a mite infestation or is it a louse infestation, but we can look at infestation level. So, you know, based on this study, you know, low louse levels might actually be causing a change in the birds more than we thought before. So really trying to refine, and this is what we would call our economic threshold, is how many parasites before we need to do something, or how many parasites before we start to see economic impact. And also the timing might be important. So are young birds more impacted by an infestation than older birds? And all of this information is going to feed into decision-making for pest management, because really at the end of the day, people want to know what to do about parasites. That's my number one question. Okay, well, how do we kill them? And that's important, but it's also important to make sure that we put our energy into controlling parasites when they need to be controlled. And so all of that information that I presented here is going to help feed into our decision-making process. With our last few minutes here, I do just want to talk about a little bit more about cage-free environments, because this is our future, at least here in California, but I think it's only a matter of time before we see this spread across the US. And I spoke today about the northern fowl mite and chicken body louse, which we know and are well-established parasites. And again, this is because they live on the chicken and they don't care where the chicken is. But if you look at these environments from an arthropod standpoint, these are very rich, resource-rich environments. And we expect to see more parasite diversity as we transition to these cage-free systems. And now it's very hard to get onto commercial properties. So I'm going to present information from a backyard survey, because from a parasite perspective, these backyard systems are very close to those cage-free and pasture-raised commercial birds in terms of what the parasites would have as resources. And so this survey I conducted when I was a PhD student. So this was back in 2015. So it's a little bit older, but we surveyed chickens all over Southern California, and we got our hands on the birds, and we actually either used an insecticide to get the parasites off, or we washed the birds, which was an interesting experience. And I want to show you what we found. So this is the chicken body louse here in the bottom middle. That's the one I've been talking about today. But we actually found 6 different species of lice, which is very high diversity, much higher than we would ever see in a commercial farm. And this was actually our predominant taxa. So we saw lice on almost every property. They were very, very commonplace. And again, most of these lice are assumed to be feather feeding and maybe not impacting the birds. But based on what we have found recently with chicken body lice, I wouldn't take that information at face value. We also found the northern fowl mite, which we were expecting to find. This is our common mite. But we also found the chicken mite or poultry red mite. And for the international audience, this is outside the US, the primary ectoparasite of poultry. Very common in Europe and other regions. And their life history is a little bit different from the northern fowl mite. So they're still blood feeding, they still can reproduce very quickly, but instead of living on the bird, they actually live in the environment. And so you'll find them in cracks and crevices, in the nest boxes, on the eggs. And I'm going to show a quick video here of the property in California. So they're here in the US, they're a wild bird parasite. So it's really only a matter of time before they make their way back to commercial poultry. And this, I'm going to poke it with a stick because that's what you do when you're an entomologist. And these are just teeming with mites. So very, very high levels. And they're even more challenging because they're in the environment and you don't know where they are. So this really is our future of parasite. Like, we're going to have to be dealing with the chicken mite. We also found stick-tite fleas. Stick-tite fleas are not a poultry-specific parasite. Much of everything else I've talked about really is poultry or chicken. Stick-tite fleas can be found on mammals, and which means that you could have ground squirrels or rodents possibly bringing them onto the property. And they differ from your typical cat flea in that they actually embed themselves in the skin of the birds. And so the adults are feeding on the bird, and then they lay their eggs without even unclasping themselves. They just hang on there and they're popping eggs out into the environment. And so now you have an environmental pest because the immatures are developing in the litter while the adults are blood feeding. So this is something else we would expect to see more of, especially in any environment where the birds have access to the outdoors. We also found Nematocopptes mutans. This is the scaly leg mite. So this is related to mange that is in domestic animals we might see on a cat or a dog. And these mites burrow into the skin under the scales of the legs. And these are the microscopic, you really need to have proper diagnostic techniques, but you can start to see the effects of it. The white, scaly, really poor looking legs. And what happens when this is left untreated is it can cause secondary infection, or offers the opportunity for secondary infection, and it can cause lameness very quickly in these birds. And finally, bed bugs. How many people knew that bed bugs could affect poultry? So this is the same species. I know I shouldn't be this excited, but bed bugs are really cool. So this is the same species that can feed on humans, and they, just like when we think about a human infestation, they're going to hide in the cracks and crevices during the day, just like the chicken mite. So they have a very similar life history here. And then they're going to come out at night to feed. And so they're going to come out and get their blood meal and then retreat back. So having these complex environments, all these hiding spots, is really ideal for something like bed bugs and chicken mites. And these are just some bed bugs that were hanging out with me, but this is a picture from a poultry facility. And these white things, these are the eggs, and then the adults and the immatures will be hiding. And all of this dark on the wood, this is all the digested blood that has been excreted by the bed bugs. So this is indicative of just like how many bed bugs there were, if this is all bed bug poop here in this corner. So yes, bed bugs are definitely a potential parasite as well. So not only can we potentially see an increased diversity, But in our backyard survey, we actually saw a lot of instances. 31% of our birds had at least one parasite on them. And this is going to start to complicate things like economic impact as well as management, because now you're not dealing with a single parasite or a single arthropod, you're dealing with multiples, and they might have different life histories or different environments they're in the poultry house. So this is definitely something that we need to be cognizant of moving forward. Now, if I haven't completely grossed you out and you're curious, more interested in learning about what types of parasites are in the US, I'm actually conducting a commercial poultry survey right now. It kicked off in the middle of COVID, so we haven't had a lot of success, but now as things are starting to normalize and I actually have, a lab to come into, we're trying to get this started again. We're not going on to any properties. And this is, from day one, we knew biosecurity was of utmost importance. So the way we're doing this is we are sending cardboard traps to producers with instructions for how to put them out and how to collect them. And then we have them freeze them before they send them back to kill anything potentially that could be in there. As much as I love parasites, I don't need to become personally infested with everything. And then send it back, and we pull apart the cardboard and we process what's in there. So this is what it looks like under the scope when we find a lot of mites. So this is obviously free. We can provide the information to the producer after we process the samples if that's what they're interested in. It's confidential. We obviously don't share any information about where it came from, just which region in the US. So we're not even doing state level. So if this interests you, or you might have any producers you work with who might be interested, you can find more information on my lab website, or you can just email me directly. So with that, thank you so much for your attention. I have so many people to thank, lots of collaborators. This is definitely a multi-disciplinary approach to this work. And I'd be happy to take any of your questions.
Great, thank you so much, Dr. Murillo, for that wonderful talk. I've certainly learned a lot, and I've never seen anyone excited about bed bugs except when working with entomologists. So everybody has their thing. So we do have a few questions. One of them is, what are some common ways that people can treat for mites and lice? And is reinfestation common once they've been treated?
That's a really great question. So I will say that once mites get onto a property, it's very hard to get rid of them completely. But you don't necessarily have to get rid of them all completely. You just want to keep their levels low from an economic standpoint. When it comes to treating, I actually have more slides, but we don't have time for that. It's complicated because traditionally treatment has been spraying the birds. When they're in cages, you can go through and you can spray the birds. In a cage-free environment, we need to be more creative. And I have done some work using dust boxes filled with sand and diatomaceous earth, food grade diatomaceous earth. And that offers an opportunity for the birds to dust bathe in the insecticidal material on their own. And we saw very good mite and louse control using that system. But dust bathing is complicated. I've said this like 3 times today, and not all the birds will dust bathe equally. And we have only been able to test it on a relatively small flock. We haven't been able to test this at the commercial level. If anyone wants to do that, call me. So that is a potential thing that could work, but really needs more refinement before we can make solid recommendations on farm. We've also had success using sulfur dust in little hanging bags. And this is published work. You don't have to be very fancy. You could use socks, like just something that's a little permeable. And what we found is that if the birds brush up against it and just get a small amount on them, it worked really well to control parasites. But again, at the commercial level, you would have to figure out where to put these. And it might be like every few nest boxes or near the feeders or something like some sort of resource where the birds are going to come in contact with it. So I think there are ways to do it, but it's going to take a little bit of creativity. And we definitely need more tools to manage parasites in cage-free environments.
Definitely. Another question kind of related to treatment, and I don't know if you know this. What are your thoughts on the use of fluorolaner in treating mites?
So fluorolaner is a product that's licensed in Europe, and it is in the water. And it will probably be great if it once it gets to the US. But of course, with any sort of therapeutic, you have to be worried about resistance. So because mites reproduce so quickly, they're really good at developing resistance. And just to, very briefly, I don't know. I think it would work, but I don't know much about like the long-term use or if it could be rotated with anything or what the overall management strategy might be.
And then another one is there a relationship between heat stress and mite infestation potentially? And is there a way to address some kind of a study where you can kind of look at that relationship there and the ability of the birds to kind of combat both?
Yeah, so that's a really interesting question. So for northern fowl mites, I don't know much about heat stress in birds, but I do know that northern fowl mites don't do well in hot weather. And this might be because they are on the bird. So when the weather gets warmer, so the mites are on the feathers, and if this is the skin and the feather goes up, as it gets warmer, the mites will travel up the feather to get further away from the bird as a way to thermoregulate. So at some point, it still gets too hot for the mites and they actually start to die off. And so here in Southern California, we have major mite issues in the winter, and in the summer, we have a relief, at least from northern fowl mites. So for that species, there probably isn't a interaction with the heat stress because, again, I don't know a lot about heat stress in birds, but I would think that if the birds were starting to get heat stressed, the mites have already died off. That's not necessarily true for the other parasites. So for the chicken mites, they seem to do well in warm weather off the host, but I don't know enough about their interaction to comment on how they might be affecting the heat stress in the birds or the timing of when that might be happening.
Okay. And then another one is, are there pathogens that are potentially of food safety importance that these parasites might harbor?
That's another great question. So there's not very strong evidence that any of these parasites are very good vectors of pathogens, but they might be good reservoirs. And that's something that really needs to be looked at. I know that some work has been done in chicken mites in Europe, but here in the US, I don't know if for example, if there was salmonella, what you might recover from the parasites. And especially these parasites that are environmental pests, if you were to depopulate a flock and they were to persist in the environment, if they might have the pathogens either on them or in them and might be either mechanical vectors or if the birds ate them, because that can definitely happen, especially during preening, if there might be some pathogens associated with that. Definitely something I'd be interested in looking at further, but we just don't know right now.
Okay. Yeah, I guess kind of complicated, I guess. And then I guess on a practical level, are there some kind of early type of indicators that producers or backyard people need to be aware of? I know you mentioned preening, but I guess that assumes they know what the baseline level is.
Yes, yeah.
So how bad is an infestation typically before people start to notice there's an issue?
Talking to producers, they tend to notice when the workers notice, and they usually notice when there are mites on the eggs. And by the time there are mites on the eggs, you already have thousands of mites on the bird. So you're really past the critical threshold. What I tell backyard producers who might spend a little bit more time observing the birds is if you want to spot check the preening birds and spot check the males. And I know commercial, they probably won't have males, but at the backyard level, if you have a rooster, they tend to harbor more parasites and earlier, which is a physiological difference because of testosterone. So if you did want to spot check that, if you can catch the rooster, that's like a whole nother thing, right? That could be your like beacon, like the thing that you're checking periodically. But unfortunately, we don't really have that refined level yet. And you're right, you really do have to have an understanding of like what is normal for my birds before you try to notice anything abnormal.
Okay, and then I guess we have time for maybe two more. So one more question is the link between dust bathing and ectoparasites has often been assumed, but kind of in light of what you found, what are your thoughts on that kind of relationship?
It's really interesting because that is, one of the earliest thoughts about dust bathing is that it was an ectoparasite. And I know that I don't want to misspeak because there are people who do this in poultry science who are much better at it than I am, but the idea that it's to keep feathers in good condition and that it might be socially facilitated and it might be based on sunlight and environmental cues. I think all of these things are true. And, if there is an ectoparasite link, we just aren't looking at the right thing. So maybe there's something about the feathers that changes that I'm not measuring that may be linked to the parasites in some cases, but not in others. So I know that's not really a very good comprehensive answer, but it is interesting that in our studies, we always saw one flock that was infested that had more dust bathing, but not in the other flock. And it wasn't the housing because we rotated our housing and we looked at that. So there's just, different cohort of birds. I definitely think after working with cage-free birds, the idea that birds have personalities and there are different birds and different makeups, that is beyond my own understanding. I would agree with that. Like there's definitely just some flocks that got along better than others. And maybe that is a factor that I'm just not capable of measuring currently.
And that leads perfectly into the last question. So we had our earlier speakers kind of talk about some differences in behavior and things like that. So are you aware of individual level bird factors that make some birds better able to cope with parasites?
Oh man, I wish I did. And that's one of the reasons why we take so many individual bird measurements is to try to better understand. And so from a parasite perspective, we are introducing birds for a flock. We're trying to experimentally control that. But ultimately, there's natural variation among each bird. And if you had a natural infestation that was not, facilitated, you would see about 80% of the parasites on 20% of the birds. So they are not homogeneously distributed in a flock. And so there are a lot of physiological differences among birds. So you have the immune responses, which weren't part of this study, but I would love to introduce and like try to bring that all together. You probably do have resource access. So, something that we didn't look at was access to food. And even though there was plenty of food, you have the pecking order and how that might influence birds and that might have downstream effects. And then of course that kind of goes into behavior and how the individual birds perform behaviors, but also how they might be interacting with each other. So all of this is to say that it's very complicated, and at any one of these levels, you might have an effect that downstream is affecting the parasite levels. And if we had individual birds, you might see different effects than if we had them together in these flocks.